something amazing and maybe unexpected has started happening with LLMs. I think this may blow your mind, so check this out. Humans and LLMs have similar performance on abstract reasoning tasks and similar internal representations. Plus, there's some evidence that reasoning models are more human-like, potentially at the cost of absolute accuracy. So this is heavy-duty stuff, and thanks once again to Import AI Jack Clark. Researchers with the University of Amsterdam have discovered some correlations between how language models and humans reason about abstract sequences. In everyday language, what does that mean? LLMs are starting to think like humans. The research is the latest to show surprising correlations between not only the capabilities of AI systems, one system to another, they mean, but also how problems get represented inside human brains and LLMs. So this study extends recent work aligning human and LLM neural representations on perceptual and linguistic tasks to the realm of abstract reasoning. So, before this brand new study, they had already had other studies that showed that on perceptual tasks, visual tasks, and linguistic tasks, which is what LLMs were originally created for, right? Humans and LLMs are similar in many respects, and now it's extended to reasoning. So the study looked at 8 open source LLMs. So what was the test they used to determine this similarity? The test asks humans to look at a series of shapes, for example, a star, a moon, a bicycle, a star, a moon, question mark, and fill in the shape that completes the pattern instead of the question mark, in this case, the bicycle. LLMs are asked to do the same, but with text. This is a very basic test, albeit with patterns that increase in complexity. So they made the test more and more complex in patterns, and what did they see? They find that there is a significant gap in terms of capability between humans and AI systems. That is, until you scale up the size of the LLM, and then they begin to agree. So, what does that mean? This is actually a huge point. It means that the effort to increase the size of all these frontier models to make them more representative of human thinking is working. It's working. So where do LLMs and humans agree? To explore whether internal representations from the LLMs and humans align. This is how us and AI represent stuff internally. The authors built a representational dissimilarity matrix called an RDM. An RDM is basically a similarity map of how a system organizes information. The idea here is to see if LLMs and humans mentally organize stuff similarly or differently. The results show that the larger LLMs and the humans have some amount of agreement, suggesting a genuine but subtle alignment between human reasoning processes and LLM representations. This means that reasoning models are more human-like, and the reasoning models being the latest frontier of AI development. It's working. A particularly interesting comparison comes from Llama 3.370b, so that's a 70 billion parameter model, and its derivative DeepSeek R1 Distill Llama 70b, and I'll explain what that second one is in a second. So both of these models share the same underlying 70 billion parameter transformer backbone. The base model, Llama 3.370b, relies solely on large-scale next token prediction. So that's pre-reasoning model, right? AI originally was built as a prediction model to predict, given a string of words, what the next word is. Whereas DeepSeek R1 is distilled, which means trained to imitate a teacher model, chain of thought output on a curated data set. So basically, they took Llama 3.3 and narrowed it down to reason better, and then fine-tuned with reinforcement learning. And my viewers know that the Nobel this year in physics was the breakthrough of reinforcement learning because it works. It led to the creation of reasoning models. So that distillation step resulted in a clear trade-off. In comparison to Llama 3.370b, the reasoning optimized variant trades about 7 percentage points of accuracy, 75% versus 81.75% accurate. And by the way, humans were just over 82% accurate. So very similar at the reasoning level. Very similar now between humans and large language models. However, the 7 points reduction in accuracy resulted in a 2.6-fold increase in human likeness. So giving up a little accuracy made the DeepSeek LLM very similar in reasoning to the way human brains reason. Fascinating. So encouraging step-by-step reasoning might therefore bring about more human-like error patterns. So why does this matter? I've already told you a few ways along the way, but research like this shows that LLMs and humans are looking more and more similar as we make AI systems more and more sophisticated. Long story short, AI is on the development path to mirror human reasoning. Therefore, I expect in the future we're going to want to treat LLMs and humans as being more similar than different. He says, I tend to subscribe to the worldview that things that behave like other things should be treated similarly. So that last statement he made about treating LLMs and humans as being more similar than different is very striking. Basically, what he's describing is an artificial being, an artificial human being. Do you get it? That's exactly what is happening. Organic human beings and artificial human beings. That's until AGI and superintelligence, at least, when human reasoning capability is far exceeded. So this is huge stuff for several reasons that I've mentioned. One, the proposition that AI is now becoming very human-like in its capabilities. Number two, that the step from predictive model to reasoning model was exactly what needed to happen to make LLMs more similar to humans. And finally, this theoretically starts to lay the groundwork to remove distinctions between artificial intelligence and human beings. No wonder, given that this has been happening, that AI is becoming more and more human-like, that more and more people are emotionally attaching to an artificial intelligence. This then is not surprising. So this is huge. This is actually a huge study and its implications. What do you think? What do you think about the study, what it said, and what it means? Let us know in your comments below. Also, please like, subscribe, and share this episode. That really helps us with the algorithm, and believe me, we need your help right now. And finally, please consider supporting us on Patreon. We need your financial support to continue to grow the channel and expand our capabilities and the ability to give you more and more resources to cope with the massive wave of automation that is now here. It's here now. See the very next episode for yet more proof of what I just said. So thanks so much. We'll see you next time. Take care.